Okay, in this video what I'm going to do is I'm going to explain how the whole drain tank and everything works, and explain how the function of the water goes through, and how that depresses all the mechanisms and how things work inside of it. I'm going to explain where to drill the holes for this tank, and also how big the holes are, and also going to go and talk about the parts of this thing. So the first part of this video, I'm going to show you where the water goes in from this thing. The water enters in from the feed tank in through a tube that goes right here into this barb right here. Goes in and goes into a float valve, which is it's normal. This right here is an upside down float valve here. It normally has a little ball on the end of it for the flow and whatever. But for this purpose, I've converted it to like a flow switch so that the flow of the water triggers it rather than the level of the water. So that's what this thing here is a little float valve, and it goes up through the float valve when the float valve's open. So see right here, so as you can see, the plunger came out like that. That means that the float valve is open, and that means that since the plunger is pulled out of there, the water is allowed to flow from the feed tank up through this tube here into the operating tank. This flows into the bottom of the operating tank, is where this tube leads to. And what happens is when the this right here would be the siphon. When the operating tank eventually fills up with water, what will happen is that the siphon will get filled up. It'll go over the top of the siphon, trigger the siphon, go down through here, and this will be the end of the siphon right here. And don't know if you can see it or not, but right there, you see that little fitting there at the top? Right there is the end of the siphon. Now pour down into this tray here. When it pours down into the tray goes down like that, because what happens is this, I'll explain the mechanism later here, but the tray gets depressed, and when it gets depressed, as you can see, the plunger here is pushed inward, and I'll close off the circuit here, and the water will keep on draining through the action of the siphon out of the operating tank. So the water will keep on draining out of the operating tank through the siphon and keep this thing depressed. And as it keeps on coming out of this thing, it'll just create vacuum more and more inside the drain tank, because it just keeps on draining out the operating tank without anything to replenish it from this tube here. So that's how that whole mechanism of the water works. And then the wastewater that comes out through this tray here, because the tray has a few slits in the sides of it that the water can drain out of. It'll just fill up in here and then go out through this tube right here on the end. And this tube can be hooked up to like either a condensation pump if you want to pump the water back into the feed tank for like a demonstration, or you can send it back to a river or something else like that, in case you don't want the area around your Hydrautomat to get all muddy. So this right here is this will allow you to hook a hose up and carry the hose out to wherever you want to dispose of the wastewater. And going on here now to explain the actions and the mechanisms, kind of explained some of them, how this float valve works and whatever. The float valve's turned upside down, by the way. But as you can see, whenever stupid hole. What happens is when the this switch here is down, the float valve is closed, and when this is open, this is up, the float valve is open like that. And that's the action of the gate here. This right here is basically, this will be filled up with a little bit of weights too. This is to it basically forms a weight that'll displace the counterweight. And as you saw on the patent, there's a lever, right? Well, I replaced that with a pulley system, so that this right here, this swivel eye pulley here would be actually it's a fixed eye pulley, would be the fulcrum. And this right here, this little tray that can be filled with weight, with BBs or something to vary the weight of it, this right here would be the counterweight. So what had happened is this thing would normally keep this up like this right here. This counterweight would keep this be pulling down on the wire, and that would be pulling this tray upward. But what will happen is when the operating tank fills up and triggers the siphon, siphon will start pouring into that switch down there, and the switch will eventually become heavier than what this counterweight is. So what it'll do is it'll pull itself down, the counterweight will go up, and then what it'll do is it'll depress. So, and then what will happen is eventually the operating tank will drain out. There'll be no more water left in it to drain out through the siphon, or at least not enough of a flow to replenish this the weight in this thing, and the weight of this thing will go down. This will become lighter, and this will end up being heavier than the switch. And I'll just pull it back up into the open position all over again, and trigger the pressure cycle and fill up the tank. So that's how the mechanism works with this thing. And show you where the holes are to drill. First start off, we have a hole drilled with a hole saw here. I always recommend using a hole saw because it's a lot cleaner and stuff. I don't recommend using like a normal drill bit or something. Anyway, I don't. Anyway, I would just I drill the hole here for a 3/4 inch bulkhead fitting. Right here, you have a hole drilled here. You have a hole drilled here, or wherever around the perimeter of the tank. Or if you want this drain tank to be located, you don't want this thing to be on the bottom, but you could have a shelf below it or something. So if you want to drain this down to something else, you could put this fitting on the bottom. It's all up to you. But I have this. The drain tank is the final, basically the tank closest to the ground. So I don't want this draining out to the ground because you know, I have to drill through the bottom of the shelf, and it's just going to be a mess. If that makes any sense to you. Anyway, this thing would be this thing's usually drilled on the side, right here. We have a hole that's got a decent amount of room in it, so you could put a 3/4 inch tube in here, but you have a decent amount of space so that this thing can move around if you need to. And that'd be for the outgoing tube right here. Then we have a hole that's drilled for the siphon. And I would recommend just getting a bulkhead fitting and a barb fitting instead of this thing, because the street pipe's expensive. I was doing this for I had things set up a different way, and that's why it's going off like this. All you need to do is just get a bulkhead fitting with another barb fitting sticking out of it, and then drill a hole through the top of the shelf, and this thing can just run directly up to a siphon, and then go into the operating tank. So that's all you need to do with this thing, is just have a siphon going from the operating tank, loops up where the feed tank is, comes back down, and then feeds directly into this. And the hole only needs to be as big as the fit the bulkhead fitting in, right here. And this right here, this would be this is like a 2 by 2.5 or 2 by 3 inch hole. This is always drilled kind of. I would rather drill this toward the middle here. This hole, I would highly recommend drilling this as middlemost as possible to this length right here. So like half this length. This point here is where I'd have the center of this, and just have a little area for this wire to kind of move around. So in case it goes up or whatever, you don't have any, it doesn't catch on anything. You just have an open space for it to move around at. There's no potential hang-ups. So that's what this right here would be. Yeah, that's it for the holes. And let's see, what else? Well, I guess we'll go into the parts now. So we just have normal bulkhead fittings and barb fittings. I would recommend using a bulkhead and barb fitting for this here. This doesn't need any kind of fitting whatsoever. Right here, I highly recommend you don't use a fitting because you can just run a pipe up through it. This right here would be a bulkhead and barb fitting here. And have a float valve right here, turned upside down. You also have a coupling and a male pipe thread to a barb fitting here. But we could also do instead, because the way this float valve is constructed, you see there's a male pipe thread there that comes out of the top. You could just get a barb to a female pipe thread And you don't even need to go get a coupling in that case, so you just put that on here. And this tray should be one of the more complicated things. That thing's most likely makes me get this thing out. Hold on a second. Anyway, the other two components to this device, took this apart so you can see it better. The first component would be just the counterweight, and this could be a box or a soup can or whatever you want, as long as it's kind of waterproof, that doesn't get corroded or destroyed by the water. You have a wire coming up through it right here, and you have a bit of a loop so you can clip it on to the pulley right here, so you can take it on. You can put it on or you can take it off if you ever want to. You know, that makes it a lot more flexible in what you can do with this thing. It only is attached if you ever need to move things around or take it off like I needed to show you. So that's basically all this is just a you have a wire here with another ferrule, and then you have a straight one going up through and a loop right here. So that's all this right here is. And this is a bit more complicated. What I used is, I'm going to show you here what I meant by the slits here. Let me show you. That's what I meant by the slits right here. You can see how the wire can flow out if it ever needs to. So that when the wire falls into this tray here, it can just drain out through these little slits here, and you can adjust just by compressing things together just how much water can come out at a time, or you can kind of open it up like that to regulate things. And as you can see, there's been no sealing or anything like that done, and that's just so it can drain out, and it also saves the work too. So that's why I haven't soldered this or connected in any other way. So that's all this right here is just a straight piece of metal that's been folded and cut. Preferably this right here would be shorter than this right here, so that the weight of the water, when this shaft is laying, at it was laying completely flat and level, what will happen is the water will want to run down this little slope here and collect right here, so it'll build up in this part of the switch system instead of over here, because there's not anywhere near as much leverage here as there is over here. So that's why I have it like this. And just have put the shaft in. I have I think like a 10-inch shaft or a 1-foot shaft or something that I got here. That comes with the float valve. And I just drill 2 holes, centermost as possible, run it through the length of the tray. I have a piece of Gorilla Tape here at the end to keep the thing from sliding off. See, it's kind of getting pushed off a little bit there over time. So you might want to put something else to better fasten it down, but that's what I use for the time being. And for the end of this thing, right here, try and get the light here so you can see it. I just have 2 holes. Try and make it as symmetric as possible so you have the best balance on this thing. And I just have 2 wire loops on here. You have it connected, have them crimped together by ferrule so they don't move around or whatever. And I have this other little thing here to keep it from sliding within the ferrule in case there's any slippage. And I just have 2 wires here going up into this little clip so that they connect at the tops here. And at the same time, be taken off and removed and played around with if you need to. So you can take this off if you need to. And it hangs up like this. Hangs as balanced as possible. And then you can clip the end of the pulley onto this end here. So that's how the switch works with the whole device. So I hope this kind of explained how everything works. That's how we have the whole device set up. And also, I remember, I also want to stress, try and get a wire pulley. Don't get one of the pulleys over at Lowe's, because what they do is they like to stop up and they're very chintzy. They're not very smooth. These wire pulleys are. This is a 3/16" cable, and I got that because what it said, what the guy told me at the hardware stores, this was a 3/16 inch. This is not a 3/16 inch wire. This is a 1/16 inch wire. So make sure you get a 1/16 inch pulley for your 1/16 inch wire, as opposed to this 3/16 inch pulley. And also make sure you get a swivel eye instead of a fixed eye like this one is. What it means by fixed eye is that if you clip this here, it wouldn't be able to move around. But a swivel eye, you could clip this here, and there'd be kind of like a there'd be a mechanism here that this thing could twist around freely with no problem. So that's the drain tank assembly, and that's how to make the thing. You know, you just drill some holes into it and insert the tubes and whatever, and it's a pretty simple device. Works very easily, and now we're going to go on to the next video. Okay, what I'm going to do here is I'm going to make a quick video about setting up the whole switching apparatus here. Because a little tray there in the bottom, a lot of the time, because of the valve and because of the float valve in the back, what will usually happen is the float valve has some resistance to it, so that even if this counterweight here did have some weight and stuff in it that would automatically want it to pull down, a lot of times, because of the resistance of that, and sometimes like the pulley and some other stuff, what could happen is the thing can stall. So that even though there's enough weight here to pull that tray down, what happens is sometimes it might just like stop midway, it doesn't go the full way down, or when it's going up it might stall or something like that, and that's not good at all. So what you want to do is you want to make sure that the tray has enough weight in it so that this thing gets pulled up here, right, to overcome the mechanical resistance, so that you don't have any stalling when the weight's going up. When the tray is being pushed down by the siphon, you don't want this thing to stall halfway or kind of like slow down, and the weight is still, and the valve is still open a little bit. You want it to fully close when this is going up, so you don't want any stalling there, and that's why you would put weight into the tray. And then in order to get this thing to rest in the default position, so that when there's no water going through the tray here in the bottom, the counterweight will just naturally want to pull the tray up and try and, you know, go toward the ground by force of gravity. So that normally it sits like this. So you would then fill the tray up. After you fill up the tray up, you would then fill up this counterweight with some BBs or rocks or whatever else. I would recommend stainless steel ball bearings because they don't corrode. You know, it's not pretty when things corrode, and that's what that orange dusty residue is in the bottom of the tank, is the corrosion from these little copper coated BBs I was using, and they aren't very corrosion resistant, I can tell you that. So probably try stainless steel. That'll be your best bet. So anyway, you would fill this thing up with enough weight so that it'll pull that tray down with the weight in the tray. It'll just pull the tray down like this when there's no water in it, so that when the water drains out of the tray, this takes over, brings it back in default position until the operating tank fills up. When the operating tank fills up the whole way again, siphon trips, the tray starts taking on water along with the weight inside of it, and that causes it to pull back up again. So that's what you need to do in order for a for this thing to operate smoothly, is you need to put weight in both of them. And I would recommend putting weight in the switch there in the drain tank first before you put weight in this counterweight. And another little bit of advice, because you can see how this shelf is. It's got a little lip here. So as this thing goes down, you want to catch there on the top of the shelf, or it might catch here too. So what you might want to do is get a flat, smooth piece of plastic. I kind of bent it too, like this, so that it'll, you know, the counterweight will just catch it like this and slide up and down. And that's what I want to do with this right here, so that it won't have anything to catch on. Just have a smooth surface. So I'm going to find a way, probably take like Gorilla Tape like I did with the other one, and just tape it on the back and fix it to this right here, so we don't have an issue with that. So there's another piece of advice is make sure that this thing can't catch, and just probably the best way is get like a flat piece of plastic that's perfectly kind of bent like that, so it can just go off and slide off the thing. So that's the end of this.